So previously we have covered Parseval's theorem, which dictates that the absolute square of the Fourier transform, and if we integrate over d omega, is the same as 2 pi times minus infinity to infinity to ft absolute square dt. And it has many interesting applications, and I gave several particular homework. Another homework is if ft and ft is given by t to the n and 0 minus 1 to t 1, then you need to calculate the Fourier transform. Then definitely, using Parseval's theorem, we have the following relations. D omega is same as 2 pi over 2 minus 1 to 1 t to the 2n dt, and equal 2, 3, 4, 5. Oh, by the way, we are going to have a final exam on December 14, 22, and therefore today's class will be the last class. And it is unfortunate that the sudden increase of the COVID has forced me to do an online class, but I hope you have good luck with your final. One last topic is convolution. Convolution of ft and gt. So this is a convolution sign is defined as the following integral: ft prime gt minus t prime dt prime, or minus infinity to infinity f t minus t prime gt prime dt prime. And let's say ht is ft times g of t. Then the Fourier transform of ht, that h tilde omega, is by minus infinity to infinity ht exponential minus omega t dt, which is given by minus infinity to infinity ft prime gt minus t prime dt prime, and exponential minus I omega t dt. Let me stop for brief. So we can dt prime dt, and we have ft prime gt minus t prime exponential minus I omega t, and we can have minus omega t prime exponential I omega t prime. So this is basically 1, right? And I told you before that in mathematics you can do nothing by multiplying 1. So this becomes tt prime ft prime exponential minus I omega t prime and minus omega to infinite tt prime gt minus t prime exponential I omega t minus t prime. So here we set u as t minus t prime. Then this becomes the following integral: minus infinity to infinity tt prime ft prime exponential minus I omega t prime, and t prime becomes du prime, so minus infinity minus t infinite minus t tu gu exponential minus I omega u. However, if you add something to infinity, is still minus infinite. This is still infinite. So it becomes I'm going to rewrite the previous result ft prime exponential minus I omega t prime and minus infinite to infinite tu gu exponential minus I omega u. So this becomes the Fourier transform of ft, and this becomes Fourier transform of g omega. So therefore becomes f omega g omega. So Fourier transform of ft convolution with gt becomes f omega g omega. So this is more like if you regard ft as an input and gt as a system, then input system, then the final result is the following: gt minus t prime ft prime tt prime. This is output. Then output can be represented. The Fourier transform of the input is f tilde omega. The Fourier transform of the system is g omega. Then output is simply f omega g omega. As an example, assuming the system response function is given by the following. This is ugt minus 1, 1, 1 gt. Sorry about the alarm. And say ft is t exponential minus at squared. Then ft tilde gt is minus infinity to infinity gt prime ft minus t prime dt prime is simply minus 1 to 1 t minus t prime exponential minus a t minus t prime square dt prime. Let's say t minus t prime as u minus t u is tt prime t prime is t minus u. So the integral becomes t plus 1 t minus 1 and u exponential minus au square minus tu. So t minus 1 t plus 1 u exponential minus au square du. To set u square as 3, then dv is 2u du. So this is t minus 1 square t plus 1 square exponential minus av dv over 2. So 1 over 2 1 over minus a exponential minus av t plus 1 square t minus 1 square is 1 over 2a exponential minus a t minus 1 square minus exponential minus a t plus 1 square. This is ht. On the other hand, the Fourier transform h omega is f tilde omega given by g omega is I DAT pi over a exponential minus 4a over omega square times twice over omega sine omega. And I'm going to stop here today. So this is the end of my class for this semester. And the final exam covers from the beginning to end. And I hope you have a good luck. Thank you for attending my class for this semester. Thank you again. Bye.